Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about hypothesis test between two population means coming from independent samples. So let's get started. Researchers conducted a study of 60 randomly selected soccer players and concluded that frequently heading the ball in soccer lowers players' IQs. The soccer players were divided into two groups based on whether they are 10 or more, whether they're received or whether they are whether there are 10 or more headers, 10 or more headers per game, whether there are 10 or more headers per game. Averaged. So that's whether they averaged. So a researcher conducted a study of 60 randomly selected soccer players and concluded that frequently heading the ball in soccer lowers the players' IQs. The soccer players were divided into two groups based on whether they averaged 10 or more headers per games. Per game. Mean and standard deviation of IQs are reported as. So there are two groups. One group is received fewer than 10 headers, and the sample size n is 35. The sample mean is 112. The sample standard deviation is 10. And then there was another group which averaged 10 or more headers per game, and the sample size is 25. The sample mean is 103, and the standard deviation is 5. Do these data support the researcher conclusion? Test the relevant hypothesis at a level of significance of alpha equal to 0.05. So let's do this problem. So solution. Let 1 is equal to group that averaged fewer than 10 headers per game. 10 headers per game. And let 2 is equal to group, this is P, group that averaged 10 or more headers per game. Headers. So let me correct that. 10 or more headers. Ten or more headers per game. Let me clear that. And we'll also reduce the, and then this actually. So the first one is group that averaged fewer than 10 headers per gram, and group 2 is the group that averaged 10 or more headers per game. Okay. So the information we have been given is N1 is equal to 35, x1 bar, this is the average IQ, sample average IQ is 112. And then S1 is equal to 10. Also, the other set of information that we have been given are N2 is equal to 25, X2 bar is equal to 103, and S2 is equal to 8. Okay, so let me create some space for myself. So move this up, and then we'll go back on this. And let's switch the color of the ink. Okay. So our null hypothesis is H sub 0 is mu1 equal to mu2. Remember, 1 is the group that averaged fewer than 10 headers per gram, and 2 is the group that averaged 10 or more headers per gram. And the alternate hypothesis is the group that received 10 or fewer headers per gram. Their IQ is greater than the IQ of the group on the average who received or who averaged 10 or more headers per gram. So mu1 is greater than mu2. So the mean IQ of the group that received 10 or fewer, less than 10 actually headers, which average less than 10 headers per game, their IQ is greater than the IQ of the group which average 10 or more headers per game. Okay, so in other words, the same hypothesis can be written as, if I subtract mu2 from both sides, H0 mu1 minus mu2 equal to 0, null hypothesis, and the alternate hypothesis is mu1 minus mu2 is greater than 0. Okay, so we have to calculate a test statistic. Okay, but before we can calculate the test statistic, okay, let me create some space for myself. We have to do some more calculation before we can calculate the test statistic. So first we need to do the calculation for V1. Actually, we need to calculate the degrees of freedom for the t-test we are going to do. So we are going to do a t-test, but we have two samples coming from two populations, so we have to calculate the degrees of freedom. And the degrees of freedom is given by V1 plus V2 square divided by V1 square N1 minus 1 plus V2 square N2 minus 1. Okay, so what is V1? Okay, so V1 is S1 square by N1, which is equal to 10 square by 35, which is equal to 2.857. And what is V2? V2 is equal to S2 square by N2, which is 8 square by 25, which is equal to 2.56. Okay, then we will plug this in the equation for the degrees of freedom, the values of V1. V1 is 2.857 plus V2, which is 2.56, and the whole thing is squared, divided by V1 square. So it is 2.857 square by 35. N1 is 35 minus 1 is 34 plus V2 square. This is V2 square. V2 square is 2.56 square divided by N2 minus 1. Remember, N2 is 25, 25 minus 1. Okay. So let's move this a little bit up. And let's do this calculation. So degrees of freedom is equal to, I'll use my calculator. First, I will do the numerator calculation, which is in parentheses 2.857 plus 2.56, close the parenthesis, and then square by pressing the x square key. And that is equal to 29. This is 29.344, you might say. And that is to be divided by 2.857 square x square divided by 35 minus 1 is 34. Okay, divided by 34. And that is equal to 0. This is 0.24. Okay, plus 2.56 square divided by 24 is 0.273. So we can do 29.344 divided by 0.24 plus 0.273 is equal to 0.513. 0.513. Okay, is this? Okay. And that is equal to so 513. So that is equal to 29.344 divided by 0.513. And that is equal to 57.2. Okay. So now we'll calculate the test statistic. So let me create some. We need the degrees of freedom for the combined sample of N1 and N2, because then we will be able to find the critical value for that particular degrees of freedom. But let me first create some space. I'll calculate first the test statistic. So the test statistic Did you quit? Don't quit. I will show you an easier way to do this problem. I'll give you a hint at the end of the presentation. So please stick around. I appreciate that. So test statistic is T. It is a t-test because we do not know the population standard deviation. And the formula for the test statistic is we compare the difference between the two sample means, and the hypothesized value of the difference in the population means is 0, as given in the null hypothesis, divided by square root of S1 square N1 plus S2 square over N2. So T is equal to x1 bar minus x2 bar. So it is 112 minus 103, and that is compared with the hypothesized difference in the population mean to be 0, and then square root of 10 square by 35 plus 8 square by 25, sample size of 25. So this is equal to 9 divided by square root of 2.857 plus 2.56. Okay. And that, if you use your calculator, the test statistic is T is equal to 3. So we'll do the whole thing again. So 9 divided by second. So clear, I'm doing the denominator. second x square gives me the square root. Inside the square root, 2.857 plus 2.56. And that is equal to divided by 2.327. So the test statistic is 9 divided by 2.327. And that is equal to 3.867. So that's the value of your test statistic. Okay, remember this is a right tail test. Okay, this is a right tail test. Okay, so my degrees of freedom I know. Okay, so let's draw the picture of the test statistic or the t distribution with 57.2 degrees of freedom. So if I create some space for myself, yeah, I'll change the color of the ink too. Okay, and then I'll create some space. Okay. So I'm doing the t distribution. I'm drawing the t distribution. Okay. This is my t distribution. Do not quit. I have some surprise for you at the end. Okay. So t distribution, center t is equal to 0. My degrees of freedom is 57.2, which I calculated before. Okay. And my alpha. So this is a right tail test. Why? Because 80 was mu1 minus mu2 equal to 0. Alternate is mu1 minus mu2 greater than 0. Age is pointing to the right. It's a right tail test. Right tail test. Okay. So my alpha value, level of significance is 0.05. Significance is 0.05. That means area of rejection is equal to 0.05. Okay. So that means this area on the right tail, okay, rejection region, reject 80 in this area, and area of rejection is equal to alpha is equal to 0.05. Okay, so we need to find this critical value, T alpha. T alpha is the critical value of T, such that we reject 80, such that we reject 80 if test statistic T, statistic T is greater than T alpha. Now the question is how to find this T alpha. Well, the area to the right of it is alpha is 0.05 and the area to the left of it is 1 minus 0.05 because the total area in the curve is always, T curve is always 1, from which I took out 0.05 in the right tail. So the unshaded region is where I do not reject 80 and its area is 0.95. So how do I find the critical value of alpha? So I go second in my calculator, TI-84. I have to use TI-84. So TI-84, okay. Second, then verse. So I'll write it down, second button, then verse button, then scroll down to in T. We have to use in T, okay. So scroll down to number 4, which is in T, and area. The area you have to type in is the area to the left of T alpha, the critical value, which is 0.95. Degrees of freedom is equal to 57.2. And then we paste enter and enter. Okay. So area is 0.95. Degrees of freedom is 57.2. And I paste enter and enter. And T alpha, paste, when I'm paste, I have to enter twice. Okay. And my T alpha, the critical value of T, is equal to 1.67. Okay. So T alpha is 1.67. Now, let's make the decision. Our test statistic. Remember, our test statistic is 3.867. So, and they move. Since test statistic P is equal to 3.867 is greater than T alpha E, okay? Decision. That means 3.867 is to the right of this T alpha value. Decision is reject 80 because it is on the right tail. It's on the right of the T alpha value. Okay. So conclusion. Our conclusion is at alpha equal to 0.05, there is enough evidence to support HA. To support HA. What is HA? Mu1 minus mu2 greater than 0. Now, I'll give you a hint. I told you I'll give you a hint at the end of the presentation. This is the long way of doing it. What is the short way? Okay, I will do it for you. So I press stat button in the calculator. Stat button. This is stat. Okay. Stat button, then highlight test on the top row. Then we scroll down to sample t-test. The reason we are using t-test is because we do not know the population standard deviation. And hit enter. Okay. Now let's walk step by step on what we have to punch in. Okay. So my input should be on stats. So bring the cursor on stats in the first line and hit enter. So that is flashing on top of stats. Okay. My x1 bar is equal to 112. Type in 112 for x1 bar. My sx1 is 10. sx1 is 10. Okay, so type in 10. My n1 is 35. My x2 bar is 103. Okay, so type in 103 for x2 bar. My sx2, type in sx2 is 8. 8. My n2, so increase some more space. my N2, type in N2 is equal to 25. Okay. The next line is my alternate, which is mu1 is greater than mu2. So next line is the alternate. So mu1, put the cursor on greater than mu2 and hit enter. Okay. And then for pooled, the next line is pooled. Okay. So mu1 greater than mu2 is my alternate. The pooled should be always no. That means I'm not assuming that the population variance for population 1 is equal to the population variance for population 2. They're not equal, so we did not pull them, so pulled is no. Okay, put the cursor on no, and then go to the next line, actually 2 lines down, is calculate. So what are we going to calculate? We are going to calculate the test statistic, which we did previously by using the calculator. We calculated by hand, and let's see how close we are, and then we'll look at the p-value. So the test statistic by this formula T, or by this calculator T, test statistic, this is your test statistic, is equal to 3.8668. And what is your p-value? P-value is the next one. It is p-value is equal to 1.42. It cannot be greater than 1. So there is something at the end, is E minus 4. What does it mean? It is 0.000. Then the first digit starts at the 4th place. First number is at the 4th place after the decimal. So p-value is the probability of getting a test statistic as extreme as 3.8668. Okay, now compare p-value with alpha. Remember, alpha is your level of significance, is the area of rejection, is equal to 0.05. So P is 0.0001. P is less than alpha. So what is my decision? Same as before, but this may be an easier way to do the problem. This was my hint or my tips. So P is less than alpha. So decision is same as before. Decision is reject 80 because p-value is less than alpha. And conclusion is at alpha is equal to 0.05. There is enough evidence to support HA. Evidence to support HA. Support HA. Same conclusion as before. What is HA? Mu1 is greater than mu2. So I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, please share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another interesting problem, interesting solution. Thanks for watching. And you know my channel has solved all kinds of math problems. So please take a look at that. I appreciate it. And thanks for watching. See you next time. Take care. Have a nice day.